Hello everybody, it's Brett. I wanted to show you some more of my Forth stuff that I've been working on. Um, a bit of an operating system. Again, I'm working on yet another operating system. I'm going to load up the Legs virtual machine. It's a Forth virtual machine that works for C. It compiles on a Raspberry Pi in Linux, compiles in regular old 86 Linux. It compiles on my Cocoa. Not in C, but in assembler at least. So here we are in a Forth environment, and I'm going to launch into, if I can spell it right, launch into my kernel. And my kernel is accepting commands, and I'm going to look at my first process that's been started when the kernel was launched is the actual outer interpreter. What you actually see me typing into here is the outer interpreter. Here's words. All the words have been defined by Forth. So look at our process list here, and we see that process 0 is running. Don't be too worried about the other numbers here. This is a timer on the end. We can start up new tasks. We can start up a sleepy task that's just sleeps and spins. And he's going to start up as task number 1. We'll start up Itchy, who just prints out a word every couple minutes, couple seconds. He'll be process number 2. And we're going to start up Verby, who sits on a communication channel and waits for communication. He's going to be process number 3. So if we print our process task using PS, we see that we have 4 tasks running. We have the outer interpreter, and we have our 3 new tasks that we started, all sleeping or waiting for something to happen. I stopped Itchy from working by issuing this toStop. I issued his task ID number returned from the thread function right there. And stop will stop him. So if we print the list, we now see that process number 2 has actually been stopped and is in the stop state. And we are going to start up a cool kernel. We're going to have the Forth interpreter look up a word called clocker, and we're going to start that as a thread, and it's going to be thread number 4, as you can see the printout there. Now if we do a task list, now we have some more tasks running. We have number 4 here, which is sleeping, waiting to increment the clock. And we also have another task here that's been started with a task ID of -1, FF. It's not actually our task. It was actually spawned by the clocker task. So tasks can spawn other tasks, of course. And the clocker task actually is running up here. Its output is just every 3 seconds. It wakes up and prints out the clock in hexadecimal. So we have hexadecimal numbers for a clock in the corner of our screen, and we continue on working with our, making new Forth words. Test. Ooh, let's make the hello world. Yay! And we can make a new word. We can test out that word, and in a couple seconds, our clock will pop back up and tell us what time it is in hex. So I don't know if it gets any more geek than that, but we can actually kill tasks. Like, remember, we killed, or we stopped Itchy from happening right here. So we're going to go back to him, and we're going to actually kill him. And he will go into a zombie state. You see number 2 is now a zombie. He has all of his kernel references have been released, and his memory's all been wiped other than the task structure. And then we're just going to go issue a wait for, and that'll return his return value of that task. So we can actually wait for tasks to die too. For instance, we can do test, and we're going to sleep for 200 seconds, 200 hex. We're going to sleep for. We're going to drop, and we're going to exit with 55 as our. Oop. Okay, so now we have a new word that sleeps for 200 hex, and then exits the system. Exits the task will self-destruct and send a return code of 55 back. So, and what we're going to do is we're going to load up his execution token, send it to the threading, make him a thread, print out his ID number, and now we're going to wait. And now we will wait for him to die. So that's why it took a little bit of time there to come back, because the test thread was actually sleeping, And then he exited and then told I issued the wait command here in the interpreter, which tells, which receives the event. No, scratch that. When test dies, it sends a signal back to the outer interpreter to kick back on. And tests will all share these things. It's a regular kill, start, stop, process control type stuff. And we're actually going to collect our child process's state, and it returns the return of 55, which is what tests sent it. And you'll see that now task number 2 is no longer in our list. So basic Forth multitasking. Other than that, it's a regular Forth machine. So hope you enjoyed. If you have any questions, email me.